Welcome students to next part of tablet. So in today's class we are going to see about tablet coating and the coating defects. So let's see what are the contents. So tablet coating process, we are going to see what are the different types of coating, what is seal coating, sugar coating, what is the film coating methods, and what are the different film formats that we are using. And next is problems in tablet manufacturing. So these all points we are going to see in today's class of the tablet. Now see tablet coating process. Now once the tablet has been formed, there is a process of coating. Now why we are doing this coating? There are some uncoated tablets also, the conventional uncoated tablets which we have seen in part 1. So that are also there. So there is some objective behind coating of the tablets. So we are coating the tablets because to mask the taste. For example, if a tablet drug is having some bitter nature, then while swallowing it will give some effect, so to mask the taste, odor or color of the drug. If any if the color is not acceptable or if it is having some objectionable odor, then in that case we are using tablet coating to provide physical and chemical protection of the drug. For example, certain drugs are sensitive to moisture. Certain drugs are sensitive to moisture, means they will degrade or they will give some reaction when it will come in contact with the atmospheric moisture. So in that case we are giving coating, so to avoid or to protect from the physical and chemical degradation. Next is to control release of the drug from the tablet. Control means slow release of the drug over the period of time. So if you want to give control release, if you want the drug to be released over a period of time, then we are giving control release of the drug. It will release the drug from the tablet. Now to protect the drug from the GID. Now we know that whenever patient will take the tablet, initially it will go into the acidic condition. So for example, drug is not stable in acidic condition, then we are coating the tablet as enteric coated so that it will be stable in the acidic pH, but it will release the contents in the intestinal. Because of the pH difference, the coating will dissolve and the drug will release. Next is to avoid incompatibilities. For example, two drugs are there. If mixed together, they will create some interaction or some reaction will occur. There will not be compatibility between them. Then we are giving tablet coating. One drug will be in the coating, the another one will be in the core part. So that's how the tablet coating will occur. Next is to provide physical elegance. For the aesthetic appearance also the coating can be done. So these are the different objectives behind the tablet coating process. Now see types of coating. What are the different types of coating? So seal coating. So to prevent moisture penetration into the tablet core. Just now what we discussed is if the drug is sensitive to moisture. So to avoid the penetration of the moisture into the core part of the tablet, we are giving seal coating. So in that shellac, remember this one, shellac is an effective sealant. It acts as a sealant. Due to polymerization of shellac, tablet disintegration and dissolution time increases. Definitely, coated tablets will have different disintegration and dissolution, and uncoated tablets will have different disintegration and dissolution. So this was about the shellac. Zane. Zane, it is an alcohol soluble protein derivative. Remember, it is soluble in alcohol. They may ask you question. So remember, Zane is an alcohol soluble derivative. From the corn is an effective sealant. Zane, it is obtained from the corn. Remember, it is obtained from the corn and it is an effective sealant. Zane and shellac. Next is subcoating. Next is subcoating. So it is applied to round the edges, whatever the tablet edges are there, to make it as a round, the subcoating is given. It is by applying a sticky binder to the tablets. The binder solution will be prepared and it will be applied to the tablets, followed by dusting of subcoating powders and then drying. Whatever the subcoating, after subcoating, the dusting is done and the powders are dried. The tablets are dried. Next is syrup coating. Syrup coating is nothing but a sugar solution. So that is because of smoothing or coloring one. Sugar increases the tablet weight up to 50 to 100% because If you add sugar into water, it will become viscous. Due to that, the tablet weight will also increase, and that will range from 50 to 100% depending upon the viscosity, depending upon the percentage of sugar solution or the syrup one. This will vary. It cover and feel imperfection in the tablet surface. If any some holes are there or some imperfections are present on the tablet surface, then that can be covered using the syrup coating. And to impart desired color to the tablet, it, for example, if we want certain color, that in the coating solution only certain colors are added, so that it will give some color to the tablet. So to impart color also. Next is polishing. So tablets can be polished in a standard coating pans by carefully applying powdered wax in a suitable volatile solvent. So powdered wax will be there, that will be added to suitable solvent, and round coating pans are present. So it is carefully applied onto the pan, and the pan will be rotated. Because of the rotation, the uniform coating takes place. So these are the different types of coating. So see, film coating method. So that is a pan pour and pan spray method. So basically this is rotating. Here you can see this is a clockwise motion of a tablet bed. Tablet bed means not individually tablet will be coated. Okay, so a certain amount of the tablet will be taken, 500, 600 minimum quantity. So that entire tablet group, tablets are known as tablet bed. Okay, so that will rotate. Because why rotation? To form the uniform coating. So see here, this is a solid pan and this is a spray gun. Spray gun means coating solution is sprayed onto the tablets. Spray gun will spray the coating solution. This is a tablet bed, and this is also moving clockwise motion. And drying air duct. See, if simultaneously the coating solution and the drying should takes place, because if the coating solution is going on, there are chances like tablet will stick together. So that should not happen. Simultaneously the drying of the tablet should takes place. So here coating solution and here drying solution. So because of that, drying air duct is also there, and this is the exhaust, inlet and outlet. So this is the front view of the diagram. Next are what are the ingredients in coating. What are the ingredients in coating? So first is non-enteric, means which will not release into intestine but they will release into the stomach. So first is HPMC, that is hydroxypropyl methyl cellulose. Next is hydroxypropyl cellulose, polyethylene glycols, ethyl cellulose, Next is methyl hydroxy ethyl cellulose, Next is povidone, which is also known as PVP, polyvinyl pyrrolidone. Next is acrylate polymers and eudragit, which is known as eudragit acrylic polymers. And next is sodium CMC. Now let's see what are the enteric materials used. So the enteric materials means the materials which will release into the intestine, and that will be intact in your acidic environment. So that is CAP, cellulose acetate phthalate. Next is acrylate polymers, eudragit L and eudragit S. PVAP, polyvinyl acetate phthalate, and HPMC phthalate. So these are the different ingredients used in the process of coating. Film formers and the enteric one. So remember the examples which are non-enteric and which are enteric. Now plasticizers in the film. Plasticizers are useful, or they are added to give the flexibility to the film. So the recommended plasticizer level is 1 to 50% by weight of the film former. 1 to 50%. Castor oil. What are the different plasticizer added? Castor oil, propylene glycol, low molecular weight PEG, surfactants, that is twine and span, they are used as plasticizer. So these are the different plasticizers that can be used in the film. Next is opacant. Opacant means if we want to provide uh, the tablet from the direct sunlight, so that gives the opaque nature, means it is not transparent. So the fine, what is added in that one? Fine inorganic powders used in coating solution. Remember titanium dioxide, here it is given TiO2, titanium dioxide. So that is added in the coating solution to give the opaque nature. So fine inorganic powders used in coating solution to provide pastel colors. To provide pastel colors. So the examples are titanium dioxide, silicates, silicates like talc, aluminium silicates, sulfates like calcium sulfates, oxides like magnesium oxides, and hydroxide like aluminium hydroxide. So these are added in the coating solution as the opacant. Now coaters, with the help of how the coating takes place. So most coating process use one of the three general types of equipment. Standardized coating pan like Pellegrini pan, immersion sword system, and immersion tube system. So these are the different coaters that are useful in the process of coating. Now the next important is fluidized bed coater, that is FBC. So fluidization of the tablet mass is achieved in a columnar chamber. Now which is that chamber? So this is the chamber. So this is FBC. So here you can see this is a bottom spray. The spraying will be there here. This is a coating solution. Coating solution will go from here. And this is a peristaltic pump that will pump the coating solution. And these are the nozzles. From here the spraying of the solution will take place. Inlet and outlet will be there for the heat exchanging. And these are the filters. Now see, the movement of tablet is upward in the center of the chamber. From here it is upward and the center, and then fall towards the chamber wall. Move downward to re-enter the airstream of the bottom of the chamber to that airstream for the drying process. Now next is coating solution is continuously applied from a spray nozzle. This is a spray nozzle. Here some spray nozzle will be there from which the coating solution will be continuously applied. Is sprayed onto the top of the cascading tablet bed by nozzles located in the upper region of the chamber. So the spray nozzle is located at the bottom and it is sprayed onto the top of the tablet bed in the upper region. Now it can be top, spray can be from the top, it can be from the bottom, or it can be from the horizontal, that is a tangent direction. So the different approaches of FB coater: top spray, bottom spray, tangential. Now remember, bottom spray is also known as Brewster process. This is very important. They may ask you question like Brewster process is a type of which approach. So it is a bottom spray. Remember, bottom spray is the Brewster process, and the tangential, the horizontal, it will be rotor process. Horizontal, it will be rotor process. Remember this one. Now this was about the coating. Now what are the problems in tablet manufacturing? What are the problems in tablet manufacturing? So the defects related to tableting process are as follows. So capping will be there related to the process. Okay, whatever the process is there. So the preparation, the granulation. So that because of the process, these are the different parameters. Like capping can occur, lamination may occur, cracking may occur. Capping is due to entrapment of the air in the granule material. Entrapment of the air in the granule material. Lamination is also the air entrapment only. Cracking is due to rapid expansion of the tablets when deep concave. This is a convex structure. Bulging means concave, convex, and the steeper like this, it will be concave structure. So when deep concave punches are used, if the rapid expansion of tablets takes place, then the cracking occurs. Now next is the defects related to the excipients like chipping. It is it is due to very dry granules. If the granules are dried, then the chipping may occur. Sticking, picking, binding we are going to see in the next part. Now next is the defects which are related to more than one factor, like mottling. It is either due to colored drug. Mottling is nothing but uneven distribution of the color. Uneven distribution of the color. So it can be that uneven distribution can be due to colored drug, improper mixing of granule material. For example, granules are colored and those are not mixed properly. Then there will be uneven distribution of the colors. Dirt, if it is present in the granular material, or oil spots by using oily lubricants. There are certain oily lubricants which we are using, and if because of that some oil spots we will get, because of that some uneven color distribution may occur. So these are some of the defects related to more than one factor. So the defects related to machine, if it is something which is related to machine like double impression will occur with those punches who has engraving on them. You might have seen about the embossing punches. So if it is there, then the double impression may occur. So that is due to the machine defect. Now let's see one by one the defects. So first is capping. Here I have attached the diagram. You can easily see that this is the capping one. So see a little bit portion of the tablet has been removed as a cap. It is like how you remove the cap. So little bit portion of the tablet has been removed off as the cap. So it can be like upper or lower segment of the tablet separates horizontally. It is a horizontally. It is not breaking. It is a horizontal separation. It can be either partially or completely from the main body. In this case, you can see it is a partial separation. And it removes or it comes off as a cap. So what are the causes? Because of poorly finished dies, deep concave punches are there. Lower punch remains below the face of the die. There has to be proper ejection of the punches also. Incorrect adjustment of sweep off blade. Sweep off means extra material, hopper will be there. The extra material will be swept off from the, because of the using that scraper one. So if the adjustment is not correct, high turret speed of that compression machine. So whatever the causes, we have to act according to its remedies. If poorly finished dies means we have to polish the dies properly. Next is deep concave punches, then we have to use the flat punches. Then mix proper setting of lower punches, adjust the sweep of blade properly, and if the speed is high, then reduce the speed also. So these are some of the remedies. Now lamination. In case of lamination, remember the letter L. In case of lamination, remember the letter L. So lamination is nothing but separation of a tablet into two or more distinct horizontal layers. Because it is removing as a layer, remember LL, that is layers. So here you can see 1, 2, 3 layers of the tablets. So the tablets is dividing into certain layers. So why that is happening? Oily or waxy material, if it is present in the granules. If it is present, then add adsorbents or absorbents so that the oily will not be there. It will be absorbed by the materials and hence the lamination will not occur. Too much hydrophobic lubricant, then use less amount of lubricant. Rapid relaxation of peripheral region of tablets on ejection. Once the tablet is ejected, there is a rapid relaxation. So use tapered dies. Rapid decompression, then use the pre-compression step. So these are the different causes and remedies for the lamination. Now next is the chipping. Chipping, you can see the edges. Most common, this is one is the edges is like little bit removed. The finishing is not proper. So that is nothing but breaking of tablet edges while the tablet leaves the press or during subsequent handling and coating operations. So what are the causes? Sticking on punch faces. Whatever the punches are there, the tablet material is sticking to the punches faces. Why this is occurring? Because the granules may be wet, so we have to dry the granules properly or increase the lubrication. Lubrication means we have seen the lubricants, what they will do, they will not allow the materials to stick to the walls of the dies and punches. So in that case you can add lubricant. Next is too dry granules. The granules are very dry. Then moisten the granules to plasticize. Add some hygroscopic material so that it will stick together and not to the walls. Next is too much binding causes chipping at the bottom. Too much binding causes chipping at the bottom. Then optimize binding or use dry binders. Instead of wet, we can go for dry binders. Next is edges of punch faces turn inward. If the punch faces are turning inward, the tablet is at the edge, it will be broken down. So polish the punch edges. In all the cases, we have to see whether the punches are properly done or not. So this was about the chipping. Chipping is related to edges. Okay, chipping is something related to the edges. Next is cracking. Next is cracking. So the small fine cracks observed on the upper and the lower central surface of the tablet. Small fine cracks which are observed on the upper and lower central surface. So here you can see the tablet is not breaking, but some certain cracks are observed. Why those cracks? Because of the larger size of the granules. If the size of the granules is very high, then the cracking may occur. Then in that case, you can reduce the granule size by passing through mesh or sifting the granules, which will reduce the particle size, or add fines. Next is too dry granules. Again, if soil is there, uh, it is not having water, then the cracks will occur. So what we are doing, we are adding some water. So similarly, if granules are very dried, then we can add some binder solution to make the granules moist. Next is tablets expand. Sudden expansion of the tablets also may result in the cracking of the tablets. Sudden expansion of the tablets may also result in the cracking of the tablets. Then improve granulation and also add the binders. Granulation too cold. For example, because of very cold granules also that is becoming dry, then you have to compress at room temperature. So this was about the cracking. Next is sticking. It is also known as filming. So here you can see the little part of the tablet, it is sticking to the punches. So tablet material adhering to the die wall means the tablet material, whatever the blend is there, that is sticking to the die wall due to excess moisture in the granulation. Very high moisture is present in the granulation, which is making the tablet blend to stick to the wall. Granules are not dried properly because of the moisture, then you have to dry the granules. Next is improper lubrication. Lubrication is not proper, that is the reason it is sticking to the die wall. So we have to change the lubricant or add extra amount also, or otherwise too much binder it contains, so we have to reduce the amount of binder, or if it is not working, then we can switch to other binder. Next is hygroscopic. Some material is present which is taking up the moisture. Even if the granules are dried properly, from the point of granulation to the tablet compression, within that time, these granular material are absorbing moisture from the environment. So that is hygroscopic granular material. We call it as hygroscopic, which is taking up the water molecule from the environment. So modify the granulation and compress under control humidity. Then either we have to control the granulation or change the granulation step, or else we have to compress at control humidity where the moisture content will be less. Next is oily material. If it contains some oily lubricants, then we have to add the absorbents, which will absorb the excess amount of oil. Too soft or weak granules, because of that also, then optimize the amount of binder. If too soft are there or weaker granules, then we have to optimize the amount of binder. Next is picking. So here you can see the little amount of the part, it is sticking, little amount of part is sticking, so we call it as a picking. So small amount of a material from the tablet, it's sticking to and being removed off. It is sticking and removed off from the tablet surface. So here you can see some white patches there. Why that happens? Again, excessive moisture in the granules. If it is, then we have to dry the granules properly. Low melting substances may soften the heat of compression and lead to picking. For example, compression also creates certain amount of heat. Because of that heat, if the tablet contains lower melting substances, then with the help of that compression heat, they will get melted. So because of this melting, the picking phenomena occurs. So in that case, we have to use high melting materials. We have to add some high melting materials which can withstand the compression heat, Next is to warm granules when compressing. For example, sometimes the granules are warm in nature while compressing. Then we have to cool it sufficiently. We have to cool the granules sufficiently. Next is too much amount of binder is present. If too much amount of binder is present, then also the picking may occur. We have to reduce the amount of binder. Rough or scratched punch faces. For example, the faces are not polished properly, then we have to polish the faces to high luster. Next is binding. So this was first was about the picking. Next is binding. So here you can see the tablets has been adhering to something and hence the particles are been removing. So the tablets adhere, seize or tear in the die. They will stick, they will seize there, or tear means some breaking will takes place in the die itself. So a film is formed in the die and the ejection is hindered. A die will have certain film and the ejection will not be proper. Ejection means removing of the tablet. Why this happens? Because of the coarse granules are very coarse. Then we have to reduce the granule size, increase the quantity of lubricant. Next is too hard granules. For example, granules are very hard, then we have to modify the granules. Granule material is very abrasive, then use water resistant dyes. Granule material again very warm, then we have to reduce the temperature of the granules. Next is mottling. So you can see here uneven color distribution is present on the tablet surface. So that is the unequal distribution of color on the tablet with light or dark spots standing out in an otherwise uniform surface. So it is not uniform, light or dark spots you will see. So a colored drug used along with the colorless or white colored excipients. For example, other excipients are white but the drug is colored. So the drug particles will be colored and the others will be white. So mottling may occur. Then they use appropriate colorants. Use some colorants which will uniformly make the tablet colorful. Next is a dye migrate to the surface of the granulation. During the process of granulation, a dye is migrating. So it will leads to unequal color distribution. Then change the solvent system and change the binder. Solvent system, we are the one which we are adding for granulation. Change the solvent system. Pick a solvent which will give the uniform color distribution. Otherwise, change the binder. Next is improperly mixed dye. If dye itself is not mixed properly, then the mottling may occur. So mix properly and reduce the size. Improper mixing of colored binder solution. For example, sometimes the color is added itself in the binder solution, but it is not mixed properly. Then incorporate dry color additive during powder blending step. Dry color additive. During blending, mixing of the blend, you have to add some dry color. So that can be incorporated. So these are some of the causes and the remedies. Next is double impression. So here you can see if your dyes or punches, they are having some double impression. If your dyes or punches are having some double impression, it involves only those punches who have engraving on them. only those punches who have engraving or embossing on them. Then the free rotation of either upper or lower punch during ejection, the free, because of that rotation, the double impression may occurs. Then in that case we have to use keys in tooling. Keys are like B tooling is there, BB tooling is there. So there are different keys in the tooling, so we have to use that one. So this was all about the causes and remedies, and that's all about the tablet coating and the coating defects in the tablets. So thank you so much. We'll see the next topic in the next session. Thank you.